Year 11, you should be working on nuclear radiation, alpha, beta, gamma chapter, and hopefully by now you've become familiar with these three particles, and I want to go over the main points. So our first particle is an alpha particle, which is a very heavy particle emitted from the nucleus. It's a helium nucleus which is positively charged. Now it's a helium nucleus, you'll remember from your chemistry, it'll have two protons in the nucleus, two neutrons in the nucleus. Because it's only the nucleus, it will have lost its two outer shell electrons. They will be gone, leaving it with an overall 2+ charge. Because it's got so many particles in the nucleus, two protons and two neutrons, it's a heavy particle, and it's deflected by a magnetic field because it's charged. So if it's travelling along a line here, the magnetic field will make it deflect off the line. It'll deflect a little bit. It's a heavy particle, so it's hard to deflect. Of the three particles, alpha, beta, gamma, alpha is the strongest ionizing. That means if it crashes into another particle or a cell, it will become charged. It will knock an electron out of the atom and it'll become charged. That's called ionizing power, and I've written a definition of it up here. When it crashes into a particle, leaving it charged, knocks the electron out. Now, alpha is the least dangerous of the three, alpha, beta, gamma, because it cannot penetrate the skin. If, on the other hand, you swallow it or breathe it in, it's inside you, it's a big, heavily charged particle, and it will knock into all the cells in your body and cause cancer and kill you very quickly. Now, if you wonder how on earth anybody could swallow or breathe in alpha accidentally, look up the Russian spy poisoned by alpha. They intentionally sprinkled it on his coffee or his bun or something and poisoned him in London a number of years ago. You'll be able to Google that. Now, I've drawn the alpha particle here. Two protons, two neutrons, helium nucleus, four particles in the nucleus, two of them are protons. Going on to beta, our next type of nuclear radiation that you need to know, and notice the symbol there, that's the Greek symbol, beta, alpha, beta from the alphabet, alpha, beta, gamma, the third letter in the Greek alphabet. Now, it's a much smaller particle. It's negatively charged, whereas the alpha is positively charged. It's just an electron, a fast moving electron, which makes it very light. As you know, it'll have a mass of 1/1840. Because it's charged in the opposite way to alpha, it'll be deflected. So whereas the alpha was deflected up, the beta will be deflected down. But notice how much more deflected the beta is. It's much lighter and much easier to deflect. Now, it's an electron, so it only has one negative charge, whereas the alpha has two positive charges. So it's less ionizing. If it crashes into another atom, it's going to knock out the electron and leave it charged, but less so than the alpha, which is a big, heavy, positively charged, very ionizing particle. Now, in the next lesson, I'll talk about penetration. The alpha can only be dangerous if it's swallowed or breathed in, whereas the beta can penetrate your skin and damage the cells. And I've drawn, the way we draw an electron here is no mass, -1 charge. That's the symbol for beta, showing that the beta particles can move. Gamma is not a particle. It has no charge. It's an electromagnetic wave, and I've drawn it here as a wave, an electromagnetic wave similar to light, X-rays, UV, infrared. All the electromagnetic waves travel in this way. So it's very high energy, as you can imagine. It has no charge. Remember, it's a wave. So it's not deflected by a magnetic field. It will just keep going on straight. And this is our symbol again for gamma. Because it has no charge, it's a wave. It's not a particle. It's not a proton. It's not an electron. It's weaker in terms of its ionizing power. If it crashes into another atom, it's less likely to knock out an electron and leave it charged. But it's very dangerous. It can penetrate deep into the skin, deep into your body, and damage cells, causing cancer very quickly. If you don't have those notes written into your book, will you write them in and I'll go on to the next topic, which is the penetration power of alpha, beta, gamma.